Hello, my name is Kenny Johnston. I'm the Director of Product covering the Ops section here at GitLab. I wanted to record a quick walkthrough of some of the Ops section features that we have available today. This is for the 12.7 release. I'll be largely using GitLab.com for my example walkthroughs. So this is live on available features on GitLab. I'm going to be walking through a couple of different projects that are already configured. Many of my coworkers have already recorded demos for how to configure some of the things that I'm going to be showcasing. This is an example of places where they're already set up and how you would interact with them once you've set up things like our auto DevOps features, serverless functions, incident management, metrics, dashboards, integration with Sentry and error tracking. I'll showcase a number of those. And then, as I said, there are other videos where we can highlight how you actually would set them up. Let me start by showing my screen. Okay, here we go. All right, so I'm going to start with, I'm going to show 3 different projects through the course of this, actually 1 group and 2 projects. The first is this Ken C. Johnson Apps group, which is a group that I've set up that has a couple of test projects that I routinely use to highlight our features and test our features when new functionality is available. The other one is this Pajamas design system, which is a production application that GitLab uses to host our design.gitlab.com. It uses auto DevOps, has a bunch of the monitoring capability already installed. And then lastly, this Tanuki Inc. Project that is what our monitor engineering team and development team specifically uses to test out new features and showcase the ops features. So I will be walking through various components of these. I'll try to make sure I give context when I'm switching from one to another. Let's start with this group, and this will be the bulk of the showcase usage that I show. The first thing I wanted to show is that this is a group, and one of the great features of GitLab is that you can not just attach a Kubernetes cluster in order to run your CI and deploy your application to, or multiple applications to, in a specific project. You can also attach it at a group level. And so this is an instance where there is an attached Kubernetes cluster to this project. You can see it here. And that cluster actually is where all of the applications are deployed within this group. So you can see when I have previously added this cluster using GitLab's built-in add a cluster functionality. I'll show you that here real quick. If I wanted to add an additional cluster, let's say the existing one was going to become my staging and development cluster, and I wanted to add a production cluster, you could go through this create a new cluster where I do it natively with Amazon's Elastic Kubernetes service or Google Kubernetes engine. And we can both run through this, and it has a kind of immediate selection of which account you want to use for Google, and then in-depth instructions for creating the various roles or Amazon resource names that you need in order to provision on AWS. Or you can add an existing cluster with the Kubernetes cluster credential. So that would allow you to add something like a OpenShift or any other generic Kubernetes cluster where you could get these credentials from it. You can attach to GitLab, and then GitLab will facilitate the deployment of your applications to that cluster. Let's go back to the cluster that is attached. So here you can see I added a base domain, which means any new app that I deploy automatically has a URL. That is a domain that I own. You can immediately see some high-level overview of the cluster health, including the memory and CPU usage. This is the GitLab managed application menu where you can install various applications that help you in the operation of your applications. So those include things like Ingress, Prometheus, which gave us metrics. I installed Knative in order to use our serverless functionality, and Jupyter Hub in order to showcase our notebooks capability, the ability to create and store Jupyter Hub notebooks, which are useful. We use them also for runbooks in order to have executable code that you can run against your cluster or other infrastructure. Let's look at some other things that I've done here. One interesting thing that we've added recently is this ability to have a separate project to manage your cluster. So I'll showcase this in a little while, but I've attached a project within this group called infrastructure to manage the cluster. And in this case, it's mostly going to be managing the cluster configuration, what apps are installed, and the specific configuration of those apps. I can also clear the cluster cache and remove the Kubernetes integration. And we've recently added the ability to, when you remove this integration, you can remove it, and remove it means kind of detach it from GitLab's purview of knowing all the credentials and how to interact and what applications are installed. But you can also have it remove any resources that GitLab has installed. So all those managed apps or other namespaces or deployments that GitLab has performed, you can have it kind of clear the cluster of anything that GitLab has added to it. Okay, one other thing that you can see here is that because it's a group level cluster, I have this environments tab that gives me a view of all the different environments across multiple projects that are in use on this cluster and how many pods are deployed. It tells me the total number of pods. This is maybe we can have a better experience here. In the functions example, this is obviously deploying functions that scale to 0, so there are no pods, but we should probably highlight that functions is using this cluster for its production environment, but it's not that there's deploy in progress, no deploy in progress. It's that because it's functions, it has a special, it doesn't have live pods running it at any given time. Okay, so that was an example of a cluster-wide Kubernetes integration. I want to show you one of the specific apps that I can highlight. Let's start with serverless. So this is an app that I created. I called it Haikus R Us. Just as a simple example, I ran this maybe 5 minutes ago, so it might be a cold boot. This is going to call some serverless functions in order to take these inputs of season, animal, action, and fruit and create a haiku out of it. When I adjust this, it might take a minute to cold boot that. So this is creating in the background. We use Knative, and it's creating containers to respond to this request live because they were scaled to 0 when it ran, or when I clicked this, and then so now it responded and it adjusted this to walk. I'll show you exactly how I built this function. The power of these functions, actually, the power of these functions are that it's very easy to enable your developers to quickly create functions and get them deployed without a bunch of the overhead of managing a kind of true functions service. In this case, we use underlying Knative. So let me show you the functions here. This is the functions app that's deploying the functions. In it, let me show you this, is the file that defines the functions. So I have 3 functions. You can see them all listed: echo, flip, and haiku. They have descriptions and what runtime they use and where you can find the source for them. I'll quickly show you flip or echo. They're very simple functions that do exactly what their titles are. So in flip, it just reverses any string you give, it breaks it up by spaces and flips the order. And then in echo, it just doubles it. So I don't need to show you that. The haiku function combines those other 2 and writes a haiku. So it takes 4 inputs. It calls 2 separate functions here itself. So this function receives input and then calls 2 separate functions to get different input, and then compiles them together for a response. In creating these, I wrote the simple JavaScript, and then I wrote the serverless YAML file appropriately, and then GitLab handled the rest. From then on, the functions were deployed to Knative, are set up so that if incoming response comes for that endpoint, that a container will be booted and the response will be provided based on the function that was defined. GitLab is also giving me a view into the functions themselves. Let me run it a couple more times. So in this case, you can see the fruit, carrots aren't fruits actually. I'll adjust that. Just wanted to invoke it a couple times so we can see the invocations chart I'm about to show you. So here in my operations tab, I have a serverless option, and it shows me all the different functions that are defined for this project. Let's look at this one, haikus. It tells me that I have had some recent invocations just now. I had some previously while I was preparing for this walkthrough, but it gives me a chart of the invocations, and it says there's no pods loaded at this time because my last invocation, the pod's been down. If you had kind of consistent traffic through, then you would probably come across this this functions detail page and see that there were live pods, and the pods would scale if the traffic was sufficiently high. That is an example of our serverless capability, and the core thing is that while a user would need to define, if they had a group level cluster with Knative installed, then they could create new projects with various functions. All they need to define are these serverless YAML files and write their functions in simple script, and then they can easily create and deliver those functions. The other project I wanted to show you was this Artisans. So this is an application, I'll show you the live version of it, that is a simple Ruby on Rails app. It has the ability to do basic CRUD operations on this object called Artisans. So you can look at all the artisans, you can create a new artisan, there's comments on existing artisans. There is also the ability to view a random artisan. So all of those functionality were just simple Ruby objects or Rails objects that I created. What I wanted to showcase is that this project was actually created using, or the CI/CD, the deployment of it is done with what we call Auto DevOps. Auto DevOps is a defined pipeline that you can think of it as a defined GitLab CI YAML file, a very fancy one that can look at a project, determine how to build it into a container, and then deploy that to production to an attached Kubernetes cluster. And also comes with a whole bunch of other tests that happen along the way, including our security tests, as well as code quality and other tests. And it automatically sets up what we call a review app. So I wanted to quickly showcase a recent MR to this project that had that showcases that pipeline. So this is a merge request that I created a while ago that, yeah, it has been merged. So I won't be able to showcase the review app functionality, but you can look at the pipeline for this merge request. Well, actually, yeah, I'll go back real quick. Let me show you this, just to highlight what the change is. The change is a simple text adjustment to the homepage. The pipeline that is created automatically for this merge request includes building it, as I mentioned, a suite of tests, including SAST and dependency scanning and container scanning, the creation of a review app, which is a live version in a separate isolated namespace in the Kubernetes cluster that enables the person who's performing the merge request review to get a sense of the live functionality of the test. It also then allows us to do DAST, which is dynamic application security testing, against that live app to test the security of the application more robustly. It runs a performance test against that live review app, and then this cleanup is actually the stopping of that review app environment. So this all comes, I did no configuration. If you look at my project repository, typically you have a GitLab CI YAML file here that defines your complex, a complex pipeline, like I just showcased. That is the default pipeline that Auto DevOps provides. The other thing that you get when you use Auto DevOps is, obviously, because we're deploying to a Kubernetes cluster that's attached to GitLab, we know a lot about we can showcase what's going on in the various environments. In this case, there's only a production environment. If I had a staging environment, that would also show up here. It also shows the review app environments. So as I mentioned, that one where we adjusted the application title is still running. I can stop those environments. The review app environments, if they're, I don't think these have live merge requests. I can easily stop those review app environments. I can also look at my production environment. I can redeploy from the last commit. I can, when looking at this environment, I can both redeploy the latest commit or roll back to a previous commit. And that essentially runs the production pipeline deployment job for that commit back onto this environment. So that can readjust my previous a previous merge and revert back to a previous state pretty quickly. The other thing I wanted to showcase is that as part of deploying this to Kubernetes and having Prometheus installed at that group cluster level, I'm kind of automatically getting access to metrics charts. So I can create my own dashboards, but this is the production environment. I could select different environments if I had them over the last 8 hours. And it's giving me, these are response metrics throughput and for this specific application, because we're using Ingress and it's isolated the traffic for this application. Remember, there are multiple applications hosted on this specific cluster. And then it also gives me some overall system metrics from Kubernetes. You can see there's a little bit of a spike. Let me see if I go back a couple days. I wanted to showcase that another cool thing about this, and it's a really unique about GitLab, is that we can showcase the integrations between your work as a developer creating and deploying the code and its performance in production. So one thing you would typically want to see is if, oh, there's a recent spike of maybe memory usage or latency or error rate, you might check to see if there was a recent deployment. So those deployments show up here. If I hover over them, I'm getting a little bit of a issue because there you go. The metric is, there you go. You can look at the exact commit that was performed here and what happened. So if there was an issue, you could quickly see, well, what changed, what exact lines of code were changed on that commit that was recently deployed. So those, I didn't say this, those artifacts are representative of actual production deployments to this environment. The other thing that we get by having this attached Kubernetes is access to the pod logs for this specific environment. So the production environment for this application, and again, remember there are pods from all sorts of applications running in this cluster. I can kind of log, tail the logs of specific pods to see what's happening. One thing you'll notice is there's a bunch of traffic coming in, even though I'm not visiting the page at the moment. That's because I've used this little application to force some traffic to the site. That's how we got those metrics showing. So don't normally have a bunch of traffic on this toy app. The thing that I wanted to showcase was, let me show you the live app again. So remember, there's this view random, all artisans, create a new artisan and view a random one. I can also set up a feature flag, and this is actually outside of the ops section features, but it's here in this ops tab, so I want to showcase it for you. I can add a feature flag to my code that displays whether or not that determines whether or not the random artisan link is displayed. So in this case, the feature flag's turned on, so it was displaying as I just showed. If I turn it off, it takes a little minute. We use the unleashed open source tool. It takes a little bit for that to navigate its way through the unleashed servers, but if I refresh my page a couple times, then with the feature flag off, that feature was removed. Maybe I can showcase for you quickly how that happened. I'm gonna look at this. This is my VS code for that application. I think it's in the, this is where I set my unleashed context. I wonder if it's in the view. Yeah, here is where I ask, hey, is random artisans enabled? If so, add this link. If not, that link is not added. So that's a simple code addition that I make that then enables me to use the feature flags, and those feature flags immediately show up in my GitLab interface for management. The other thing that I wanted to show here, was error tracking. Yeah, let's look at this. So this application is also instrumented for Sentry. And so I have made that connection in GitLab that there is a Sentry. Let me show you how I did that. In GitLab, I said, oh, I'm doing error tracking. Here's my Sentry URL. I have a project on Sentry.io. And here's the auth token for it and a project that I want to attach to. So then when I look in operations at error tracking, I get a list of the current errors that are that have been spotted. This one was spotted a day ago, and it has something to do with Postgres connection failure. if I look at this error, it might not have a great stack trace, but it'll show me a stack trace of where that error came from, the specific event, when it was seen, and what the release of that application was. And then I can also ignore it, resolve it, or create an issue from it. Typically, you would have multiple errors, and you can also manage from this list, ignoring or resolving. If I want to create an issue from it, it creates a GitLab issue that I can then collaborate with my team on figuring out how to solve, and eventually attach a merge request that closes this issue because I've fixed the error. Let me show you an example of, yeah, this is an example of some other issues that have been created from that same error. Yeah, so I think that's a showcase of what you get directly out of the box with Auto DevOps. And again, just a simple Ruby on Rails application. The other thing that I wanted to showcase was a place where we're using GitLab Auto DevOps for a more production-like experience, and that is with this Pajamas design system. This is GitLab's design system, design framework that all of our designers and front-end developers utilize in order to share components and make sure that we're using the same design language across the application. This design.gitlab.com is posted, the content is stored and is deployed using GitLab itself. So let's check that out. That's this one. So again, this is an example where there is a group level cluster. Look at this project called GitLab Services. There is 2 attached clusters, one for staging and one for production. The production one, you can see, has only the Pajamas, the design.gitlab.com environment, the production environment in it at the moment, but we're moving additional applications here. What I wanted to showcase was what some of these dashboards and experience looks like with live metrics coming through it in an application that is more regularly being deployed and interacted with. So this is the throughput for the design.gitlab.com, latency and error rate. You can see the memory usage. I saw yesterday when I was doing this that there was a deploy that showcased what I was suggesting, where you might see a deploy and notice some change in both behavior. This wasn't throughput or latency, didn't change on either one of these deploys. But yeah, you can see when there's a deployment, the memory usage resets and some of the CPU spikes. So again, an example of a great integration between GitLab as a application for creating and verifying your code with our great source control and CI, but then when using the same tool for production, you get a bunch of these great integrations between the 2 experiences that help people performing triage really quickly. Speaking of triage, the last thing I wanted to showcase was our incident management capabilities. And a member of our team, Sarah, did a great walkthrough video that I will post a link to. But just to showcase it really quickly, this is an example app that our monitor team uses on a regular basis. And you can set up in the metrics dashboard alerts. I'll wait for this one to pop up. I think I saw Sarah doing this yesterday. So hopefully if I do this all, we'll get an instance where the threshold was breached and an incident was created. Maybe not. There's an ability to quickly add an alert based on, I don't think I have permissions on this project. That's part of my problem, sorry. I will show you that you can add an alert. I'll show you how you can do that in this. That's not the best one. Let me choose this Artisan app that I have permissions on. So in this app, when I'm looking at a metric, I look at my metrics chart. Let's say in Kubernetes metrics, I wanted wanted to add an alert on total cores used above 0.4. So I can click on that little more triple dot, go to alerts, choose total cores. I want to know if it is greater than 0.4. Add that. It gives me this nice visual representation of the alert and would tell me, I think because I added this after it's already surpassed, it would take some additional time for it to fire. But you can easily add alerts. And in the example project, I want to showcase what an alert issue looks like. This is an actual closed alert. So this issue that's created as a result of the alert firing is auto-created by a GitLab alert bot. It creates this primary summary information, and this is the query that was used to determine whether the alert should be fired and the time that it was fired. You can easily embed the charts for the metric that fired right here in the issue. So this is a live chart that you can interact with that would update live. It can also be, you can scope it to the specific time frame, and you can attach a Zoom call in order to aid the team that's firefighting this issue in collaborating, in addition to the ability to collaborate in a kind of standard GitLab comments method. So the one other thing that you can do when it comes to incident management is, I don't have permissions on that project, but I can, in my operations setting, define a specific issue template that is used when creating those incidents. So that is helpful if you want to make sure you assign certain labels or assign it to a certain group or team, or @mention a certain group or team in the issue when it's created. In this example, I think there is a project template or an issue template in this project. Here's the incident template that they're using. So it includes an embedded metrics chart, as well as some of these slash commands that add specific quick actions to the issue when it's created by the bot after the alert firing. So let me stop sharing. Those were some quick examples of live, already set up projects and groups showcasing the ops section features. As I mentioned, there are other videos that I'll link to in the comments that are also part of the ops section playlist that this one will be added to, that showcase how you do some of that setup, including how to set up auto DevOps, how to set up incident management, how to set up serverless from scratch. But I wanted to showcase everything in a live environment real quick. So I hope you enjoyed this video. There will be many more to come. Thank you very much.